All right. Class.
Yes.
All right, good job, good job. Okay, so I know everyone's got their ear pods, you know, your headphones. Even though they're giant headphones, they are away. You know, you can't hide them, okay? So, yes, I was looking directly at you. All right. Yeah, I know. All right. Okay, so today, hashtag what?
33.
33, today's date?
A week from our birthday.
A week from her birthday.
2/10/20. Next Friday.
2/10/20, or it's going to be, okay, if we're going to do it mathematically, it is
Cameron.
B day minus 7. So you know when they're doing like countdowns and stuff like that, and it's like T minus 10 seconds. And they start counting down. So we're birthday minus 7 now. Huh? Time. What do you think B day stands for? Yeah, about that. Anyway, all right. So if you paid attention previously, what is the base on this one right here? It's 10. It doesn't have a base. So if there's no base there, it is implied that it is going to be 10. Right? So we're going to write this as an exponent to be able to solve for it without the calculators. So in this case right here, my base is 10. So the base is 10, and that is supposed to be equal to what value? 10, right? Because if you write your thing, it's going to be b to the y equals x, and then it's log base b of x equals y. So in this case right here, it's going to be equal to x, which is going to be 10. And I'm looking for the y value, right?
Yes.
Yes. Okay, so 10 to some power gives me 10. What's y? Yeah, it's going to be 1. So y has to be 1. So that's one way of doing this mentally without the calculator. Okay, so on number 2, I'm going to do the same thing. So my base is 10. It doesn't say a base, right? It's implied that it is 10. There is no b on here, right? So this is going to be log base b. And my b, which you cannot see here, must be 10. Equals, what's my x value here? What's my x value? 10,000. So in this case, I'm looking for the y. So 10 to some power is going to give me 10,000. It's 4, isn't it?
Yes.
Because 10 to the 4th power is going to be 10,000. 1, 2, 3, 4. 4 zeros. So in this case right here, 10 to the 4th is going to give me this. Are you guys seeing where I'm getting this from, or is it like not making sense? Okay, how about this? I'm going to go off to the side right here.
What side?
Right here. What's 10 to the 1st power?
10.
10 squared? 10 cubed? And 10 to the 4th? If you notice, this says I have 3 zeros. This says I have 4 zeros. So we're going to use this type of method here to be able to solve some of this stuff later on too. I'm sorry, I can't hear you. Yeah. Yeah. And so any base is going to help us. But the 0 thing only worked with 10. But, you know, you do your powers like this, and we could do it like, you know, be able to solve it. We'll do a 2 down here on the bottom. Okay, so we know that y has to be 4. Now this next one right here, again, my base is going to be 10 equals what number? 0.1. Now, if I were to write that as a fraction, how would I write that as a fraction? One over 10, isn't it? 1/10. 0.1 is 1/10. 1 over 10. So this might be a little bit easier, because if you guys remember when we were going over and doing this, what is going to give me a 1 over here? What type of y value will give me a 1 over? Say? Not 0. A negative, right? Negative values will give me a 1 over, won't it? And what power is it going to be to make it 10? -1. So this is going to be equal to -1. So a -1 would just bring it down to right here. Using that same information here, my base is 10, and that's supposed to be equal to 1 over 1,000. Again, I need to make it 1 over, so that makes it a negative, right? And so a negative what? -3 is going to give me 1 over 1,000. George, you good with this? Okay. All right, so let's take a look at this one right here. For this, you guys are going to do this. Gross. Hate that problem. All right, says my uses the fact that the square cube root of 2 is close to 1.25 and that 2 to the third power is 8. Make an estimate with log 2 of 10 equals 3 1/3. Explain my my estimate. How exact is this estimate? Okay, so I'm going to use this in exponential form. What's my base? Say 2. My base is going to be 2, and that's supposed to be equal to what number? 10. Now, I'm going to show you over here. We're going to do the same thing that we did up here. Yeah, go ahead. So, we know that 2 to the first is 2. 2 squared is 2 to the third is 8, right? It's just the 4 times 2. It's multiplying by another 2. Okay, so that's going to be an 8. And 2 to the fourth, 16. It's the previous number times another 2. So that's going to be 16. And what about 2 to the fifth? 32. It's my previous number times 2. And 2 to the sixth? Yeah, it is 64. That's as far as we need to go on that. All right, so I'm going to use this information right here. So this is what you're going to need to be able to show your reasoning without a calculator for this next test. And the next test is actually going to be on Wednesday. This is the last section before the next quiz. So tomorrow we're going to do a review, and then this is the type of thing you guys are going to have to be able to do. So use your base. So let's see. If that is my y value, I know that my y value has to be between what two numbers? 2 and 3? Not 2 and 3. It's going to be 3 and 4, right? Because 10 is between 3 and 4, isn't it? 10 is between 3 and 4, and it's going to be closer to which number? Is it closer to 8 or is it closer to 16? It's closer to 8. So an estimate of saying that y is about say 3.3 is fine. If you say 3.9, I don't think that's going to be close. 3.8, nope. Okay, this is a way to estimate where it's going to be at without a calculator. So now let's see what we get for 2 to the 3.3. So in your handy dandy calculator.
I thought you just sent that to me too.
No, we're. I did say not to, but now I'm checking to see how close I am. All right, so we said 2 raised to the 3.3. That's pretty close, right? That's pretty close to the 10 that I was looking for, wasn't it? Okay, so that is a good estimate for that. Now, does that make sense of how we did that? So I have my table. I listed it where it's located at. And then I found 10 is going to be between 8 and 16. But it is closer to the 8 than it is to 16. There we go. Are we happy on that? When you see that on a test question, you're going to be happy on that? No, you're not? Oh, probably not. Okay. Okay, so here's a couple different ones. Let's see. It says, solve this equation. Tyler writes the equation in logarithmic form. We get log base 10 of 19. Press log, enters. Okay, so we get an approximation of this. Whatever that is. I don't know. Phia? Pria? Pia? I have no clue. Anyway, follow the steps on her calculator and writes down this number. Okay? So, let's do this on the calculator, see what we get, because both of these are slightly different. Now, I'm going to show you steps on the calculator, so hopefully you guys feel pretty good about this. Now, to put this in my calculator, it says log base 10. So on my calculator, on your calculator, it's right here. It's 10 to the x. So I do control 10 to the x. So hopefully you're writing this down on your notes so you could actually remember it. Jonathan,
What?
you okay?
Control?
And 10 to the x. It's the red button on my screen right now. Okay, and it gives me a little box to enter my base. So right here, my base is 10. And then the number I'm looking for is of 19, right? Okay, so hopefully you guys have this in your notes, right? How to enter the log. Hit enter. My answer is 1.27875. All right, now let's see right here. So, what's the difference in between these two answers and my answer? What happened?
Mr. Cargo, did that mean?
You rounded, didn't we? Is that the only difference right there? They should be the same answer, but if you notice right here, they rounded to the third digit. In this case, it's a 9. But over here, third digit, it's an 8. So I have to look at the next one. So 5 and above rounds this to a 9. And we have a 7 right here. So that's going to make this one going to be a 9. So it's about, because I rounded, 1.279. So they're both correct. Just depends on where we're rounding to. All right, so for you people right now, I would like for you people to do A and B right here. So you're going to turn it into a log first and then solve for it. Turn it into a log and then solve for it. When she gets back. So turn it to a log and then solve for it. Jonathan, do you have your notebook? Okay. Did you already do these ones? Please. Okay, so let's see. I'm going to write it down to see what we should have. So it's going to be a log base 10 of 24 equals m. And m is going to be about, hold on, let me see. Jennifer, what'd you get for m? 1.38021. You guys agree? Okay. All right, so this next one's going to be a log base 10 of 750 is equal to n, and n is going to be, hold on, let me see, Karen, what'd you got? Why not? Oh, okay, all right, sorry. Yulissa, what'd you get?
2.80506.
Like that? Okay, you guys feel pretty good about this? All right, good job. All right, so let's take a look. And now these next ones. Next one's right here. Estimate each value expression and explain how. So now, I would like for you to do the estimate like we did back over here on this problem here without doing it directly in the calculator. So give me an estimate and show your work just like we did on the previous example.
Foods that we can't eat because the school can't sell it to us.
Yeah. No, because Obama. I can't sell these during the school day because it's unhealthy for you. And they would rather you eat the cardboard and chunks of plastic out of our cafeteria.
It was a stoplight that gave it to us.
Yes.
Oh, I know it's cheese.
Put some cheese on it. You got that pizza.
Oh, yeah.
How you doing? How you doing? Okay, what's our base? No, our base is 10. Remember, if it doesn't say anything, the base is 10. See? All right, let's see. Now, in this case right here, all of them, my base is going to be 10, right? The base is going to be 10. So this is going to be 10 to some y value is equal to 90. Now, I'm going to go off to the side over here. I'm going to make my own table. So 10 to the 1 is 10. 10 squared is 100. 10 cubed is 1,000. 10 to the 4th is 10,000. I think, wait, 10 to the 5th, 100,000. There we go. All right, so 90 is going to be between 1 and 2, right? It's going to be between 1 and 2, so I would say that would be about 1.9, right? Is that, it's because it's closer to 2 than it is to 1, isn't it? Okay, that's good. All right, what about this next one on B? So I'm going to have 10 to the y is equal to 1,005, right? So that's between 3 and 4, right? So between 3 and 4, 3.05. Are you taking a guess or calculating, or what are you doing? Taking a guess? Okay. So now 3.1. I want you guys to see 3.1 real quick though. So for the sake of, that's why I was asking if he was putting it in the calculator. So it's 10 raised to the 3.1. That's way big, right? Let's try it again. 10 raised to the 3 point, you said 0.5?
Yes.
Oof, right?
3.01. Oh, you know what? It's 4.005.
See? Okay, but the reasoning behind it is you guys are understanding it that it is closer to the 1, right? Yeah, 3.01. It's pretty close, right?
Yeah, it's only 3.
Okay, yeah. 3.1, I would go with that one. Just because if you don't have a calculator, you have to be able to understand or approximate it, but yeah. You said 0.1 or 3.1. I'll take either because they're good estimation. Now this one is going to be 10 to the y is equal to 9, right? Okay, 0.9, right? Because it's going to be between 0 and 1. So we're going to say that one's going to be about 0.9. Oh, let's try that. Let's see what we get on that one in the calculator. We said 10 raised to 0.9. Oh, okay. Not bad. Yeah? Okay. It's close. But you guys are understanding how we actually get these things. So that estimation, and you notice how we went from the table. We made our own little table on this to be able to show how we're getting it. Go ahead.
And the test, you have to be like the closest, or like from our head.
Just from your head, from right here. That's what we're doing. So we're estimating and then checking to see how close we are. So sometimes you're not going to have access to a calculator. So you're going to have to estimate it sometimes. And this is a good way to learn how to estimate it. We know the exponents, right? We know the powers. We just figure out where it's between. Okay? All right. Don't forget, like, share, and subscribe. Hit that notification button.